this channel I do post math videos, but usually of a more advanced nature, non-routine. And so here we have a nice integral that goes as follows: 1 over x plus x to the m. There may be no obvious way of approaching it, but we can do the following. We are always allowed to multiply by some appropriate form of the number 1 to transform. So when we do that here, it's going to look like this. It's going to be x to the negative m over x to the negative m, multiplying this integrand of 1 over x plus x to the m with the dx. This will transform and make this doable by simple u substitution, believe it or not. So let's continue down below. So x to the m negative m times 1, it will give us a new numerator of x to the negative m. And at the bottom, it's going to be negative m. Now this is a 1 here, right? So it's going to be negative m plus 1. So it's going to be x to the 1 minus m, in other words. And then here it's going to be negative m plus m, which is going to give us a 0. In other words, we'll end up with a 1 here, right? So because it's x negative m plus m is 0, x to the 0 is 1, and then dx. Now this simple step here has changed things considerably. Look, now we can say that u is equal to the following: x to the negative 1 minus m plus the 1. Differentiate this, so du is 1 minus m, x to the 1 minus m minus 1 with the dx here. The 1 here cancels with the 1 here, which means all we have left over is that du is 1 minus m x to the negative m dx. And we want this. Why? Because you see, if you look at this part, now it's matched by this part right here. And then with the dx, you see? And then we have this extra 1 minus m, but that's okay, we just divided. So it's going to be du over this 1 minus m would be equal to x to the negative m dx. So now we write our integral, so this integral symbol, and then x to the negative m dx can become just the du over 1 minus m, and then x to the 1 minus m plus 1 will just become u, basically, you see? So you just end up with this, which is pretty simple. We can just do it with the ln function. So it's going to be the following then here: 1 over 1 minus m and the ln of u plus c. But again, remember, we say u equal to this expression right here initially, correct? So we can make that replacement back. So we have 1 over 1 minus m to the ln of x raised to the 1 minus m plus 1 with the plus c. So now that we have this integral worked out, essentially, let's do it in a very specific case. Imagine we have the root of 3 and then positive infinity, and it's 1 over 1. Well, this is x plus, let's see, x raised to the root of 3 dx. Like this. So this is the root of 3 now. So this is like saying that our m is the root of 3. We can plug it in here. So that means on this side, we will have 1 over 1 minus the root of 3 this way. And then the ln here. Okay, and it's going to be x raised to the 1 minus the root of 3 plus 1. And it's going to be evaluated now between these two values, let's see, of infinity and the root of 3. I'm changing both the lower limit of integration here and the value of m to be the same value. Okay, so what happens here? Let's go through this. So, okay, this is going to stay, except you can rationalize it. So you can say like 1 over 1 minus the root of 3, and then you're going to multiply by 1 plus the root of 3 over 1 plus the root of 3 this way. And then now for this part, what happens with this part? Okay, we have to be careful because now 1 minus the square root of 3, so like this value right here, right, this value, that's less than 0, which means when you plug infinity in, I'll write it down, but it would look like ln of infinity. This infinity essentially in the limit, for x would be raised to a negative number, right? So in other words, like this. Let's pretend we can write this. Let me just erase this. Okay. So put this 3 back here, the root of 3. So now this could be that, and then plus the 1. And then you also have to plug in the lower limit of the root of 3. So let's do that on the side here. So minus this ln of, let's see, the root of 3, and then raised to the 1 minus the root of 3, plus the additional 1, and then close the bracket. Here you're going to have 1 plus the root of 3. Now what happens when these two, so 1 times 1 is 1, negative 3, and the root times the 3 here will give you a 3. So it's 1 minus 3, which is going to give us negative 2. In other words, you're going to have 1 plus the root of 3 over a negative 2 as this coefficient right here. Now this, again, because this here is less than 0, that means this part right here, right, this will go to 0, and then you're going to end up with the ln of 1, which is 0. So that means this whole term, right, this whole term basically is 0. It goes away. So that means you have just left over the negative here of that part, which is the, let's see, ln of the root of 3 raised to this 1 minus the root of 3 plus 1. Can we simplify? We have a negative and a negative, which means this can cancel this. So we'll take as our final answer, in other words, this form. 1 plus the root of 3 divided by 2, and then the ln of this, the root of 3 raised to the 1 minus the root of 3 plus 1. Well, that is it for this one, friends. If you enjoy math videos at this level of complexity and higher in different places and so on, different topics, please be sure to subscribe and like.